Welcome to 5.3, which is forces in two dimensions, and specifically it's going to be dealing with inclined planes. Now, I found this cute little picture, snakes on an inclined plane, just to kind of demonstrate the properties that are going on inside of an inclined plane. And right off the bat, here's the first thing I want you to notice. Thing number one, gravity always pulls on objects exactly straight down, towards the center of the mass of the Earth, which will be straight down in all of our problems. Now, the normal force, you'll notice that the normal force, the definition of the normal force is a supporting force provided by a surface that's perpendicular to the surface. So you've got this surface right here. The normal force is perpendicular to that surface. So that's the first really essential understanding that it takes to deal with inclined planes. An inclined plane is just anything that scientists we talk about if it's not on a perfect flat horizontal surface. So what I'm going to do, I'm going to draw myself just a quick inclined plane. Let's just make up a number. Let's say that the angle is 25 degrees. Let's put a box on this thing. Let's say the box is 10 kilograms. Let's say the coefficient of friction is 0.2. And here's the question, will it slide? Will it slide? Will gravity be big enough to overcome friction? And how big is friction? You know, like if the coefficient of friction was larger, it would be much more stickier. Will this box slide down the incline? So here's where we do this. The steps that we use to solve. Number one, draw in all the forces. Draw in all the forces. So my forces that are acting here, the first force I've got is the force of gravity. And I actually know the force of gravity because it's mass, 10 kilograms, times the acceleration of gravity, 9.8. So I'm just going to assume that I gave it three significant figures, so it comes out to be 98.0, right? Newtons. I also know there's a normal force. Common mistake number two. Well, I guess this is the first mistake a lot of people make. They think that the normal force equals gravity. Not in this case. Not in this case. The normal force is not equal to gravity. So we don't know what it is right now. And then we also have friction. Again, we don't know what this is either. We know that whatever this force of friction is, it's equal to the coefficient times the normal force. So if we could somehow figure out what the normal force is, we could just stick that in there, multiply it by 0.2, and then we've got exactly what the force of friction is going to be. So that's kind of our quest right now, is to figure out the normal force, because once we get the normal, then we'll multiply by 0.2, and then we'll just see what happens. So thing number two, when we're doing this, we look for diagonal forces. Now, we talked about diagonal forces back in 5.1, and normally we think of left and right as being this, horizontal, and up and down to be vertical, x and y. So normally when we apply it to our problem, the diagonal force in this case is going to be, we've got two of them. We've got a diagonal force here, friction, and we've got another diagonal force, the normal. It turns out there's an easier way to solve these problems. Because what you do after you look for the diagonal forces is step 3 is to resolve those diagonal forces into their x and y components. The x and y components. Now, there were two. So what I'm going to do is just like we're free to pick which direction is positive and which direction is positive, we as physicists are free to pick out what way do I want to view the problem as, which way do I want to be horizontal and which way do I want to be vertical. And it turns out the easiest way to do this problem is to rotate your reference so that the x-axis, the horizontal axis, is perfectly parallel with the surface of the incline. So now watch this problem. When I do this problem like this, I only have one diagonal force now. The only diagonal force in this case is gravity. Turns out gravity is the one that's not going up and down. So I only have to resolve one of these forces into its x and y components. Why do I want to do that? I want to do that so I can compare apples to oranges. You'll see in a second, apples to apples. So what I'll do, I'm going to, this would be its y component. We call it the force perpendicular. Perpendicular because it's perpendicular to the surface. Now, the next one we have to write, it's parallel to the surface. So do you see how this line right here is the surface? I have to make it parallel to that. So my force is going to be this force right here, parallel to the surface. This is a huge mistake that I see a lot of people making. Let me show you how people do it wrong and see if you can see the difference. What I see people do all the time is they'll draw in this first vector and then they draw the second one in like this. Oh, force parallel. Do you see how that's different? In this case, what they're doing is they're putting the right angle over here when that's not true. When you say that this is parallel and this is perpendicular, this should be the right angle. I mean, you can't say that something's parallel and then something's perpendicular and then have their angles not be 90 degrees. So I see that and people screw it up when they start to use their sines and cosines. So the correct way to do this is like this. Put your parallel on the bottom, and it's got to be parallel to the surface. Make sure that it's parallel to the surface. I can't even stress that enough. That's really the biggest mistake that I see. And then, here's what we do. You might be saying, why in the heck am I even doing this? What's the point? What I will do, I will end up getting rid of gravity. I'll get rid of gravity, and what I'll do is I'll replace gravity with two forces like this, and now check it. I move this guy here, and what I'll end up doing is I'll end up comparing how does the force that's parallel compare to friction. If friction's bigger than, then the thing stays still. And actually, the friction ends up being exactly what gravity is. It doesn't accelerate it up the hill. If you initially slide the block down the hill, then it does accelerate up the hill. But I'll compare those two. The second thing I'm going to compare, this thing, the force perpendicular equals the normal. That will always be true. And there's my horse. And remember, once I find the normal, then I plug it in here, and then I got friction, which I'll plug back into there. So that's kind of the way I'm going. I'm going to use sine and cosine to figure out the perpendicular force, and then I'll know my answer. So here's our journey. It's a little bit confusing, so don't worry. It's not that bad. I like how I have a smartboard and I can move all these arrows around to kind of show you. So first of all, I got to figure out this angle right here. And it turns out this angle will be 25 degrees. It has to be. There's a little bit of trig that goes into it. Since this is a right angle, I know that all sides of a triangle add up to 180 degrees, so this has to be 65. And I know that this angle right here is a right angle because by definition this is perpendicular to the surface. So that's a trig proof right there. You thought, man, when am I ever going to use my proofs in geometry? Well, there you did. You just used a little logic and some proofs to figure out that this angle is 25 degrees. So here I'm going to go resolving this using sine and cosine. So here's how I do this. I'm going to say that the sine of 25 degrees, and remember sine is the opposite over the hypotenuse. the opposite over the hypotenuse. So force parallel divided by 98. So then I just take my calculator and I multiply 98 times the sine of 25. So I'll pull out my magic calculator. Hopefully. All right, and the first thing I want to, I've got two of them gone now. The first thing I want to do is I want to check the mode. So just make sure, hit mode. Oh, it is in radians. I got to make sure that it's in degrees. So make sure it's in degrees. Quit. And then I'm going to take 98 times the sine of 25. So 98 sine 25. And it comes out to 41.4. So this is 41.4. And I'll do the exact same thing for the force perpendicular, but I'll use the cosine. So the cosine of 25 degrees equals the force perpendicular divided by, because it's the adjacent divided by the hypotenuse. So force perpendicular divided by 98. Back to my calculator, and I take 98 cosine 25, and I get 88.8. Boom, we got them. Step 4. The normal force and to be equal to the force perpendicular. So this back to this normal force, now it all the whole house of cards comes tumbling down. Force normal is going to be equal to 41.4. And then I put that in here. And then I put this in here. So I take 0.2 times 41.4. So that's 4.14 times 2, so it's 8.18. So this force of friction is only equal to 8.2 newtons. Get rid of gravity. So I take the force of gravity and I ditch it. And then I compare this, my parallel force, to friction. Who wins? Gravity does, baby. Gravity is going to win big time in this case right here. Gravity is pulling this thing down at 41.4. Friction's opposing me at 8.2. So really, like after I put all this stuff in, you can even ditch this stuff because 88.8 is completely canceling the. Oh, I screwed that up. Oh, dang it! I screwed that up. The normal force is supposed to be equal to 81. I did that 88.8. So this should be 88.8, and then this becomes the wrong number. I'm so sorry. So 88.8 times 0.2. So it's going to be like 17.6, I think. 17.8. Oh man, that's terrible. On a video. Gravity still wins. It's pulling it down. So going back to where I was. This force perpendicular, I can get rid of it, as I can get rid of the normal force, because they're canceling each other out. Because maybe I'm trying to find the net force here. So I just kill all these, and if you look at it, I've got two opposing forces. I got gravity pulling me downhill, 41.4, and I've got friction pulling me back at 17.8, and you can figure out its acceleration then from F net equals m. So will it slide? Absolutely. Got 2 pulling it downhill. I've got 41.4, and then I've got friction opposing me at 17.8. So you're going to pull out the calculator one more time. 41.4. 41.4 minus 17.8. Why is this slow? Now I'm going to divide it by 10, and it comes out to 2.4. Boom. So will it slide? Yes. It will slide accelerating this way. 0.4 meters per second. So I know the book's got a couple more examples, and I'm not going to go through them because I felt like that this example right here kind of hit both of those. It says a weight, it's 562 newtons resting on an inclined plane of 30 degrees. So you know this is 30 degrees. It's kind of nice that they tell you it's 500 newtons because you don't have to multiply by 9.8. That's the force of gravity. It wants to know the components that are parallel and perpendicular. So again, it's asking you to find this, which is perpendicular, and then it's asking you to find this one, which is parallel. So what I do is just use the sine and cosine. So I'd use 562 sine of 30 degrees. Ooh, and this is really cool. If it's a 30, 60, 90 triangle, all you got to do is divide by 2. That's a clever little way. So it's actually 562 divided by 2, which is 281. And then you could do the cosine. So 562 cosine 30 comes out to be 487. So perpendicular, parallel. Just using sine and cosine. And I knew that this is 30 degrees. Last problem. Person's going down the hill. How fast is the skier going 5 seconds after starting from rest? So I'll go through this just a little bit quicker than my initial one. So here's my inclined plane. It's 37 degrees. Got my skier. They are 62 kilograms. So I'm going to take 62 times 9.8. And I get 607, 610. What was it? I'll go with 608, just so I'll do the rounding at the end. The coefficient of friction, slippery, is 0.15. How fast? So how fast is definitely, I'm looking for the final velocity. And I know the time is going to be 5 seconds. Starting from rest. So I know that my initial velocity is 0. What I'm going to end up doing is just like the last problem, I'm going to try to find my acceleration from F equals ma. I'll take that a and put it in here. Solve this using, I think, this equation. VF equals VI plus AT. Yeah, sure. And then I'll kill it. So here we go. I know that there's a normal force. Don't know what it is. I also know that there's a force of friction. Don't know what it is. There's step one. Draw the picture. I haven't done really any physics yet. I've just drawn the picture. Labeling the forces. Actually, this is all the physics. I'm doing all the physics right now, and just algebra is going to be left. So look for the diagonal force. The diagonal force is going to be gravity. So I find this piece right here. It's the force perpendicular. And then I'm going to find this force right here, which is the force parallel. So pull up my calculator, and I go 607 answer times the sine of 37 degrees. That. And I'll take 607.607.6 times the cosine of 37. And I get 45. So it's 366, 485. 485. Okay, so then next step, ditch gravity. Gonna get rid of it. Bring this up here. 366. I know the normal force is going to be equal to 485. So I can now find the force of friction. It's the coefficient of friction. It's the normal force. So it's 0.15. So I take 0.15 times 485. Got 0.15 times 485. 72.8. Okay, gravity totally wins this battle. So my net force, I'm going to say that positive is down the hill. So it's 366 minus 72.8. The mass was 62 kilograms times my acceleration A. So then I just do 366 minus 72.8. Divide that by 62, and I get 4.7. So my acceleration is 4.7. So 4.7. So VF equals VI plus AT, so I don't know what the final velocity is. This is 0, the acceleration 0.7 times my time of 5. So I just multiply this by 5. 24 meters per second. So a lot of talk. I just wanted to go through a couple of these because I know that inclined planes can be kind of confusing. So I wanted to give you a few examples, but there's some true rules that we do. Number 1, draw on the forces. Number 2, look for diagonal forces. Number 3, you resolve the diagonal forces into its x and y components, and that's always going to be gravity in all of these cases. The normal force will equal the force perpendicular, not gravity, the perpendicular component of gravity to the surface. And then you ditch gravity and you start comparing. When I said apples to apples, that's what I meant. I meant compare the up force to the down force. 485 to this 485, and the downhill force to the uphill force. Notice how all the forces are now going in nice, even directions that we can do the problem.